Welcome to this chapter titled Battery Fundamentals. Energy is essential in our daily lives, but it's not always available. Batteries allow us to store it for later use. Present in our phones, cars, or solar powered homes, they ensure a stable power supply. Over time, batteries have become more powerful, durable, and accessible. In a world shifting toward clean energy, they are a key pillar. Let's begin. To fully understand the role and functioning of batteries, it's crucial to grasp some basic concepts. Definition: a battery converts chemical energy into electricity. This process occurs through a chemical reaction known as redox, oxidation reduction. Accumulator: an accumulator is a system that stores electrical energy in chemical form. It's rechargeable, meaning it can be used multiple times. Battery, cell. Unlike accumulators, a battery or primary cell is not rechargeable. Once it's depleted, it must be replaced. The difference: a battery pack is a set of accumulators. It's designed to be recharged and reused many times. The operation of a battery is based on a few key elements. Let's look at the essential components that allow it to store and deliver energy. Anode. The anode is the negative electrode. This is where oxidation occurs. The anode loses electrons, which then flow through the external circuit. Cathode. The cathode is the positive electrode. This is where reduction happens. It receives the electrons coming from the anode. Electrolyte. The electrolyte is a liquid or gel that allows ions to move between the anode and the cathode. It is essential for battery operation. Separator. The separator is a porous membrane that prevents direct contact between the anode and cathode, avoiding short circuits. It allows ion flow while protecting the battery. There are several types of batteries used for energy storage. Each has its advantages and disadvantages. Here are the main ones. Lead acid battery, the oldest technology, inexpensive but heavy and requires regular maintenance. Lifespan 3 to 7 years. AGM battery, absorbent glass mat, maintenance free and resistant to deep discharges. Lifespan 5 to 10 years. Gel battery performs well in extreme temperatures, ideal for harsh environments. Lifespan 7 to 12 years. Lithium ion battery, very light, efficient, and high performing. The most modern technology with excellent efficiency. Lifespan 10 to 15 years. High voltage batteries are capable of operating at high voltages from tens to hundreds of volts. They are ideal for powering high energy and high power devices. Advantages: higher energy density means more energy in a smaller volume, greater output power, better efficiency, longer lifespan. Disadvantages: higher safety risks. The higher the voltage, the greater the danger in case of failure. Higher cost, both purchase and maintenance. Less availability on the market. To choose a battery that suits your needs, it's essential to know its key specifications. Here are the main ones. Capacity, R. The amount of energy the battery can store. The higher the capacity, the longer it lasts. Nominal voltage, V. The average voltage at which the battery operates. Example: a lithium battery may have a nominal voltage of 51.2 volts with a range from 43.2 volts to 57.6 volts. Influencing factors: depth of discharge. The deeper the discharge, the faster the wear. Temperature, battery type, maintenance, number of cycles. How many times it can be charged and discharged before major capacity loss. 1 cycle. Full charge plus full discharge. A battery's life cycle represents the repeated phases of operation between charging and discharging. Charging. Electrical energy is stored in chemical form inside the battery. Use. The battery converts this chemical energy into electricity to power devices. Discharge. Energy gradually decreases as it's consumed. The battery eventually drains. Recharge. New electrical energy is injected to restore chemical energy and restart the cycle. To extend battery life, follow manufacturer recommendations, avoid deep discharges, Use a suitable charger store in a temperate environment. Temperature and charging speed have a strong impact on battery lifespan. Heat speeds up aging and can cause overheating. Cold reduces capacity and efficiency. Too fast charging can damage components. Tip: always follow the manufacturer's guidelines on the technical data sheet for longevity. Charging a battery isn't just about plugging it in, it involves several steps to extend its life. Bulk phase, constant current charging. First phase, the battery receives a high current to recover energy quickly. Absorption phase, constant voltage charging around 85% full, the charger maintains a fixed voltage. The current gradually decreases until it is nearly full. Float phase, maintenance charging. Once fully charged, this phase maintains the battery at 100% without incurring an overcharging risk. Equalization, optional, occasional higher voltage to rebalance electrolyte, useful for certain batteries. The way a battery is discharged affects its performance and lifespan, just like charging. State of charge SOC indicates how full the battery is. 100% ASCAR full, 0% ASCAR empty. Depth of discharge DOD indicates how much energy has been used. 0% ASCAR full, 100% ASCAR empty. Why avoid deep discharges? Deep discharging greatly shortens battery lifespan. Avoid fully draining it. How to prevent this? Use management tools to monitor and limit excessive discharge. Battery coupling involves connecting multiple batteries to increase voltage, capacity, or power, depending on the application, e.g., solar or off-grid systems. Important: always use identical batteries, same type, capacity, and technology. Otherwise, an imbalance may reduce performance and lifespan. Series coupling means connecting batteries end to end, positive terminal to negative terminal. Effect: increases total voltage, sum of voltages. Capacity remains the same as one battery, best for getting higher voltage without changing capacity. Parallel coupling connects all positive terminals together and all negative terminals together. Effect: voltage stays the same. Capacity increases, sum of capacities. Ideal for longer runtime without increasing voltage. Mixed coupling combines both series and parallel methods. Batteries are connected in series to increase voltage. These series groups are then connected in parallel to increase the total capacity. Result: total voltage, sum of voltages in each series chain, total capacity, in sum of capacities in parallel chains, the best of both worlds, high voltage and large capacity. Batteries are now indispensable thanks to their ability to reliably store and supply energy. Here are some applications: transportation, electric cars, bikes, drones, boats, even submarines. Renewable energy used to store energy from solar and wind systems, stabilizing power grids, medical sector, powering critical equipment like defibrillators, portable respirators, and diagnostic tools, electronics, powering daily use devices, smartphones, laptops, cameras, smartwatches. In conclusion, the correct battery depends on your needs, budget, and usage environment. Energy storage is crucial across many industries. It enables more efficient energy management. Advancements in battery technology continue to improve performance, lifespan, and accessibility, enabling their use in transportation, energy, electronics, and various industries. To maximize efficiency and safety, proper selection and maintenance are key to meeting future energy challenges. Thank you for your attention and stay focused on what's next.